Alright guys, this session is mainly for those who had some network problem with their phones when I was explaining the pulse width modulation, and also 7:30 also I explained, but some of you were unable to attend. So that's why I've made a different recorded session just for the pulse width modulation. Now yesterday I did explain pulse width modulation, but I explained it something like this. What I understood originally was that the pulse width modulation, because we are using the code, I'll show you the code, showed as analog, right? Now I thought that the code was actually, the signal was actually an analog signal. Alright. Now that's a wrong concept that I actually taught you guys, and I want to correct that part. Now the thing is, although we are using a function called as analog, right, it does not actually produce an analog signal. It produces a square wave or digital signal only. But let me show you what originally I explained you guys. So originally, what I thought was, this is the time. What I thought was the signal was supposed to be something like this. All right. Now you can see here, this one has a separate voltage level, this one has a separate voltage level, this one has a separate voltage level, and so on and so forth. It keeps on increasing till it reaches a maximum of 5 volt. All right. Now this can be produced. It's not that we cannot produce a signal like this. Obviously, not using the Arduino, we cannot produce an analog signal like this. So the question of producing an analog signal like this using an Arduino doesn't come. So what I thought was that, suppose this one is 1 volt, this one is 2 volt, and this one is 3 volt. Now this entire concept is actually wrong. All right. So this entire concept is actually wrong. What pulse width modulation or PWM actually means is, uh, it's something like this. The wave is not actually analog wave, it's a digital wave, and it looks something like this. The height is same, all right, the amplitude is same, it does not change. It looks a bit bad here, but still it's not like this. It's wait, so the signal is something like this. Now in electronics we learned that this is a square wave or a digital signal. Here what you see is that it's almost, please excuse my drawing, but the width that you are seeing here, if you zoom in on this portion, you will see something like this. Now this width that you're seeing is the pulse width. All right, the pulse width. Now modulating or changing, or like changing the pulse width is what the PWM is mainly based on. Modulating the width of the pulse, hence the name pulse width or PWM. Okay, so this part is done. Now what I want to teach you is something, not teach exactly, like I'm not talking as a professor, but obviously what I want to explain you is something called as duty cycle. All right, a duty cycle ranges from 0% to 100%. All right. Now consider a square wave. I'm just taking a square wave and outline. This is not actually a square wave. I'm just taking an outline of a square wave. So this is just one high, this part high and this part low. One high low I'm taking. All right. Now this 0 to 100% duty cycle that I'm talking about, what you can do, what does duty cycle actually mean? So this whole thing is actually 100%. All right. Now if I want to make, if I say you that generate a waveform having a obviously DC signal or DC waveform having a 20% duty cycle, it'll, or maybe 25% duty cycle, it will look something like this here. Now you might be thinking that why have I ignored this part. See, this whole part is 100%, no doubt, but I say to generate a 20% duty cycle waveform. This part is 20%. All right, it looks a bit odd here, but just assume it as 20%. Now this is what we call a 20% duty cycle. Now the duty cycle can be of 25%, 50%, 75%, or 80%, can be anything, as long as you are giving it under the range, taking it under the range of 0 to 100. All right. Mm, let me just erase it. All right. Now, what happens? All right. So, what I'll do now is I'll make a few waves. 25, 50, 75, and 100. I'll make with start with 0. So 0, you all know, this is 0%. All right. Is this part. And then the next one is 25%. The 25% wave looks something like this. This is 25%. Then comes 50%. 50% is another here, extra. This much is 25. This much will be 50. All right. Now comes 75%. 25, 25, 25, 75. So this is 75% duty cycle. And then the last one is a complete 100. 1, 25, 2, 25, 3, 25, and this. So this is 100% duty cycle. Now what you are seeing is that this duty cycle in a transistor means, suppose you are giving this signal to the base of a transistor. All right. When you're giving this signal to the base of a transistor, what happens is that if you're giving this number 1 signal, suppose number 1 signal, you are giving 0% duty cycle signal. That means the transistor will be off all the time. But if you are giving number 2, that is 25% duty cycle waveform, the transistor will be on. All right, it will be on for 25% of the time, and then it will be off for 70% of the time. And similarly here in the third one, it will be on for 50% and then off for 50%, and it goes on like this. This is 75, this is off for 25. But in the fifth case, you will see that it's not off, it's completely on. All right. So if you're giving this wave is also same as just a normal straight line, but this is 5 volt and this is 0 volt. Okay, this the previous one that the previous explanation that I gave you guys was that the voltage changes. No, the voltage remains same in each of these waveforms. This is also 5 volt, this is 5 volt, this is 5 volt, this is 5 volt. This does not change. That was a wrong concept that I explained to you guys. It's not, the voltage is not changing, only the width of the pulse is changing. All right.